We are looking at transformations of functions here. So we're going to start by looking at the function y equals, or you could have f of x equals the absolute value of x. And we're just going to use that function to start with. So this function is the basic function, the most basic absolute value function we can make, and it is therefore called the parent function. So if you ever hear a reference to a parent function, it is basically the simplest a function can get. So we're going to look at what different things do to this function. So the first thing that we might do to this function is we might add 3 after the absolute value. So what would happen to our function if we add 3 after the absolute value? Well, let's do it and take a look. The function moves up 3, right? It is translated up 3 units. So if I change that to a 2 instead, we would expect that it would shift up 2 units. And if I made it -5, right, we would expect it to shift down 5 units, and we see that it does that as well. So it seems like if we add or subtract something on the outside of this absolute value, it just shifts it up and down vertically. Another thing we might decide to do is to change something on the inside. So what if we looked at x minus 3? So you might take a guess at what this would do, but x minus 3 actually moves our graph to the right 3. Well, that's interesting because it's x minus 3, but it does move it to the right 3. Again, now we would expect that if we change that to a -6, right, it would move over to the 6 to the right. If we changed it to -2, it's 2 to the right. And if we did +3, we might think, okay, so if minus something moved it to the right, +3 probably is going to move it to the left, right? And it does. We could change that to a 5. It moves it 5 to the left. So it looks like inside subtraction, addition work a little bit differently. They feel opposite of what they should do, but otherwise the amount of units they move seem to be correct. An additional thing we might do is change the value outside the absolute value. So multiplying it by some value. That might be a larger number, or relatively larger number from what we're going to look at, like 4. And we notice that the graph looks like it gets narrower, right? It becomes less narrow, and that is going to be called stretched vertically. So this graph is stretched vertically because it has become more narrow. Stretched vertically is the more mathematical term for that. What do you think would happen if I changed that to 2? Well, it's probably going to do the same thing, but a little bit less, right? So compared to 4, it's less narrow. It's stretched vertically a little bit less, but otherwise it's doing the same idea. If we went really big, right, it comes really, really close together. What if we did something like 1/2? Okay, so that makes it wider. What about 1/4? That looks wider still. And we're going to call that compressed vertically. So it's compressed vertically because it's getting compressed towards the x-axis. And we would think then if we keep making those numbers in the denominator bigger, right, it's going to compress more and more. Okay, so we've done a lot of different things, but what we didn't look at here in the front was what would we do? Like, I guess we could look at this 2 different ways. What would we do to get this graph to reflect across the x-axis? There's something that we didn't do yet with this first value. And so what we might do is we might multiply the absolute value by a negative. And there you see that on negative on the outside looks like it flips the graph upside down, reflecting it in the x-axis. Here it would be interesting to see, does the same thing apply with other numbers? So if I use a 2, a negative 2, is it going to make the graph wider or narrower? Is it going to stretch it vertically or compress it vertically? And we notice that it stretches it vertically. Again, the same with a 5. But if we go the other way, right, then we see it happening where it compresses vertically. So if we were to put all those things together, we can kind of come up with this idea of how this equation would get formed. In a general formula, we get y equals a, the absolute value of x minus h, plus k. And so now we can kind of see, we slide it around, look at values of 0, 0, and 0. 0, 0, and 1. Sorry. 0, 0, and 1. This is our parent function, right? A is 1. We have just the absolute value of x. Everything else would be 0 in our formula. And again, we can see if we move h positive, it moves our graph to the right. Right? So it's a positive h because the actual function that we're looking at is x minus h. So if we put in a positive number, you get x minus 2, and that moves it to the right. And if we do negatives, right, we move to the left. So let's go back to 2 here. Again, remember changing our k. This is just moving the graph up or down. And so we might say that this point here, where h is 2 and k is negative 2, notice that that is the vertex of this graph. It's where it comes to a point. And if I change it, notice again, we have h is 3 and k is 1. And that is what the graph looks like here. Again, I can change a, or I can flip it on the x-axis still, or the line y equals negative 1 here, and that's it. Now notice that this is the exact same thing that is going to happen if we change from an absolute value into a squared function. So notice that here, let's go back to our parent function. That would be a value of 1, h is 0, and k is 0. And this is the parent function of the absolute value. This is the parent function of the quadratic. So this would be just y equals x squared, because a is 1, h and k are both 0. And so we get this graph here. Notice that with this graph, the exact same things will happen as we move h and k. So again, as we move k, the graph moves up for positive values of k and down for negative values of k, just like it did with the absolute value. For h, as we put in positive values of h, note again that the formula is x minus h, so when you're looking at it, it's going to look like a minus h, but the h is actually a positive value. Or left, and again, as we move, a gets bigger, the graph gets narrower, or stretched vertically, and as you go smaller, here, before getting to 0, the graph gets wider, or compresses vertically. And then once we go to negative, right, you have negative, fraction values, which are very wide graphs, flipped in the x-axis, and then eventually narrow graphs that are flipped down. So recognize the things that are the same about these two graphs, and it actually comes up in a number of different graphs along with this square and absolute value.